Hello, and this very brief video I'm going to look at the discriminant. There's a number of ways of solving quadratic equations. There's factorization, there's trial and improvement, or there's using the formula. Here, if I rearrange the quadratic equation into the form of ax squared plus bx plus c equals 0, I then use this formula. Just a little tip, remember, hey, I'll give you an example, here we go, 5x squared minus 3x minus 4 equals 0. In this case, a would be 5, it's the number in front of x squared. B would be minus 3, it's the number in sign in front of x. And c would be minus 4. C is the constant term, the number including its sign. Now the discriminant is this part of our formula, b squared minus 4ac. And let's have a look at this in detail. B squared minus 4ac. Why does it have such a big impact? Well, if b squared minus 4ac is negative, that is less than 0, then there are no real roots. Let's see why. If I had a negative value in here, the calculator is going to say error. You cannot have a real square root of a negative number. So if this part of our equation is less than 0, negative, there are no real roots. What about if this equals 0? Well, what happens then is there's just one real root. Let's see why. If this bit here in yellow was 0, then my calculation would look like this. Minus b plus or minus 0. Well, adding 0 or taking away 0 isn't going to change minus b, and it isn't going to change minus b over 2a. So if b squared minus 4a equals 0, you only have one real root. And of course, the most common case though is where b squared minus 4ac is not negative and not equal to 0. In other words, it's greater than 0. And that's when you get two real roots. You might be asked a question, a subsidiary question, about the discriminant and how many real roots that your equation will give you. Okay, so that's the topic of discriminant. I hope it was of some help to you. Thank you.